Hey guys, so today our lesson is going to build off of last class. Last class we were working on writing equations of lines. So if we think back through those steps, we needed to find the slope, we needed to find the y-intercept, and then we could write our equation for y equals mx plus b. And so we're going to walk through that same process today, but our process for finding slope is going to be a little different because today we're going to be writing the equations of a line that is parallel to another line, or writing the equation of a line that is perpendicular to another line. So first of all, we have two equations that are graphed, and they are parallel lines. And if we look at the slopes in the equations, one equation is y equals 1/2 minus 2/5 x, or 2x over 5. That's the blue line. If we look at the orange line, y equals 29/10 minus 2x over 5. Okay, so if we're thinking about our slope, remember slope is the coefficient of x. For both of these equations, it's negative 2 over 5, negative 2/5. Okay, and so if we look at this equation, which kind of makes sense, right? If two lines are never going to intersect, they would need the same steepness, right? And slope describes steepness, so that makes sense with this. I can take these lines and I can move them all around. What I want you guys to see is that no matter where I move it, the numbers in front of x are staying the same. Okay? So if the lines are going to be parallel, they have to have the same slope. Okay, so here y equals 7x over 6 plus 53/12. The slope is 7/6, and the orange line, y equals 7x over 6 minus 31/12, so their slope is 7/6 for both of these equations. So if they're going to be parallel, they have to have exactly the same slope. They have to have exactly the same steepness so that they would never intersect. Okay, so we're going to use that piece when we're writing equations of parallel lines. When we're writing equations for perpendicular lines, I want us to first look for the blue line. The slope is 7/6. Okay, that's the coefficient of x. For the green line, if we look for the coefficient of x, the slope is negative 6/7. So think about what you notice about those two slopes, 7/6 and negative 6/7. And let's see if when we move these lines around, you notice anything about those slopes. Okay, so I'm going to move them around. Notice as I move them, they're staying perpendicular, so these are perpendicular lines. So for the blue line, if I look at the coefficient of x, I see negative 4/7. If I look at the green, I see 7/4. For this one, for the blue line, my slope, the coefficient of x, since it's in slope-intercept form, the coefficient of x is 6/13. So my slope is 6/13 for the blue line, and my slope for the green line is negative 13/6. Have you noticed anything about the slopes? For perpendicular lines, the slopes are negative reciprocals. Negative just means they have different signs, which makes sense because if the slope is positive, the line's going up. If the slope is negative, the line's going down. So we would need one of our slopes to be positive and one of our slopes to be negative, unless we're talking about vertical and horizontal lines, right? But one slope, they're going to have different signs. So when that negative part of negative reciprocal just means the opposite sign. And then reciprocal, back to fraction land, right? So instead of 6/13, that reciprocal would be 13/6, but we don't just want the reciprocal, we want the negative reciprocal, so that's where we get the negative 13/6 from. So for perpendicular lines, their slopes have to be negative reciprocals, and that is the second idea that we're going to bring into writing equations today. Okay, so how does that connect to writing equations? Well, that comes into play in step 1. Step 1 is actually the only step that is different or new today. When we find our slope, we're going to use those two ideas. Parallel lines have the same slope, and the slope of perpendicular lines are negative reciprocals. We're going to use those two ideas to actually find the slope in step 1. And then steps 2 and 3 are actually the same as yesterday. So let's see that in action. Example 1, first of all, parallel lines have the same slope. So on example 1, it says write the equation of the line that's parallel to y equals 3/2 x minus 5 that passes through the point 6, -4. Okay, well, if we consider this equation that they give us, y equals 3/2 x minus 5, the slope of the original line is 3/2. And because parallel lines have the same slope, the slope of the line that we want would also have to be 3/2. This slope followed by these two little lines, those two small parallel lines is a symbol for parallel. So our parallel slope would be 3/2, and then we're going to use the ordered pair 6, -4 to get our x and y values. And as soon as we have that, we are back to y equals mx plus b, and we're going to plug in the x, the y, and the slope. So y is -4 equals our m, our slope was 3/2 because it had to be the same as the original equation, times x, which is 6, plus b. I'm going to use a capital B, so my 6 and my b don't look the same. We need to simplify, so -4 equals, if we multiply 3/2 times 6, we get 9 plus b. We're solving this equation for b, so we're going to subtract 9 from both sides, and b is equal to -13. So our slope is 3/2. The value of the y-intercept, b, is -13. And now we're ready to write our final answer. The equation of our parallel line would be y equals 3/2 x minus 13, since the y-intercept was -13. If you think you understand that example, I encourage you to pause the video and work example 2 and then check your answer. So example 2, in the equation y equals -4x plus 3, my slope is that value, the coefficient of x is -4. So if I want a parallel line, I need to use the exact same slope. So the slope of the parallel line is going to be -4, and we have our x and our y. So now we're ready to plug into the slope-intercept form, y equals mx plus b. So y is 4, m is -4 times x, which is 6, plus b. Simplify, -4 times 6 is -24. Add 24 to both sides to get the b by itself, and we see that b is equal to 28. So we have our y-intercept, we found our slope in step 1, and so the final answer for the equation of that parallel line is y equals -4x plus 28. Okay, let's take a look at perpendicular lines. Remember, for perpendicular lines, the slopes are negative reciprocals. And remember, the negative part of that just tells us that we need to have opposite signs. And in fact, negative reciprocals are often called opposite reciprocals. And remember, for the reciprocal, if we're finding the reciprocal of a fraction, we're going to flip the fraction or invert the fraction. You may have used that term. So let's look at example 3. Write the equation of the line that's perpendicular to y equals -2/3 x minus 5 that passes through the point -6, 7. So the slope of this original line is -2/3, and we want the perpendicular slope. That upside down T is the symbol for perpendicular. And so we need to find the negative reciprocal. -2/3 is negative. We have to change the sign. We need the opposite sign. So the perpendicular slope that we're looking for is going to be positive. And if we take the fraction 2/3 and find the reciprocal, if we flip that, we would get 3/2. So my perpendicular slope is a positive 3/2. And then I'm going to use the x and y value from the ordered pair and plug those into slope-intercept form. Y equals mx plus b. So the y value is 7. The slope is 3/2. X is -6 plus b. So 7 equals 3/2 times -6 is -9. And then if we're solving for b, we need to add 9 to both sides. And we get that b is 16. So we have our y-intercept. So then we take that perpendicular slope that we needed, the y-intercept that we found, and we write our equation, y equals 3/2 x plus 16. And that is the equation that we were looking for. If you feel good about 3, pause your video, work number 4, and then you can check your answer. So example 4, this time we want the equation of a line that's perpendicular to y equals 4x plus 3 that passes through the point 8, -3. So the only thing that we need to find before we can plug in is our slope. So our perpendicular slope. The slope of this equation is 4, and we need its negative reciprocal. This is a positive 4, so then our perpendicular slope is going to be negative. And then we need the reciprocal. Well, 4 is really 4 over 1. And if we flip that to find the reciprocal, we would get 1/4. So my perpendicular slope would be -1/4. So I'm going to use that in the ordered pair and plug that into y equals mx plus b. So -3 equals -1/4 times 8 plus b. If we multiply -1/4 times 8, we would get -2 plus b. And then our last step is to add 2 to both sides. And we get -1 equals b. So we have our perpendicular slope. We just found our y-intercept. Last step is to write the equation of the line. Y equals -1/4 x minus 1. All right, that's it. Thanks, guys.